Hey everyone, it's Group 5 Zephyr. We're back with another cool Arduino project video. Today, we're tackling something really interesting, the traffic light using Arduino. But before we dive into the details, let me quickly explain what a traffic light is all about. You know those signal lights at intersections? They tell cars and people when to stop and when it's safe to go. Simple, right? So we're diving into the world of creating a traffic light using Arduino. It's not just a fun project, it's also an awesome way to explore coding and bring something practical to life. Let's roll up our sleeves and get started on this exciting journey into the world of Arduino programming. Here's what you need for this project: an Arduino board, jumper wires, resistor, breadboard, LEDs, and USB cable for Arduino. We also need Arduino IDE for uploading the code from your computer into the Arduino board.
Connect the LDE and the other resistors according to the wiring diagram, as well as the jumper cables male-to-male for the vehicle and pedestrian lights to their respective digital pins. Then, connect the push button that will serve as the input of the circuit. After that, connect the three remaining resistors and the other jumper cables male-to-male. After connecting the components to the breadboard, connect the Arduino controller and the computer with the provided USB cable. As we connect the USB cable, click Compile button and the Upload button in the Arduino IDE to run the sketch.
Okay, now let's move on explaining the code of how it will work. After declaring the variables, we enter the setup function to configure the LEDs and button using pin mode and digital write. We've set the LEDs to output and the button to input. We've also set the vehicle's traffic lights to start at green or go state by setting the green LED to high and the pedestrian lane's traffic lights to red or stop state by setting the red light to high. Onto the void loop, int state digital read button. State is the variable we've set to read the button state of the button that is connected to digital pin number 9. Digital read is the command used to read the digital pin state, whether it is high or 1 or low or 0. Digital read passes the signal to the variable state for further judgment. When state value is high or 1, it means that the button has been pressed, and the opposite if the button has not been pressed. If state is equals to high and millis is minus change time is greater than 5,000. Change lights. On this block of code, we've used the if command to the test conditions. If state is equals to high or when the button's state is pressed or returned a value of 1 or high, and if millis minus change time, the unsigned long is greater than 5,000. The function change lights would then be called. Change lights function will then turn the vehicle's green LED to low or off, turn the yellow LED to high or on, wait for 2 seconds, turn the yellow LED off, and red LED on. Then wait for 1 second and turn pedestrian lanes red LED off and green LED on. Wait for a duration of 5 seconds or the cross times delay value. After cross times value has been reached, the for loop would be activated and would start comparing conditions. Then the pedestrian lane's red LED will turn on, wait for 500 milliseconds, then the vehicle's red LED would turn off. Yellow LED will turn on. Wait for 1 second and then yellow LED will turn off and green LED will turn on. After that, change time would record the time since the last change of lights, then return to the main program loop. That's all. Good job! And there you have it. Our button controlled traffic lights are now up and running. It's amazing to see how a simple button press can control the flow of our traffic lights. Stay tuned for more exciting Arduino projects. Join us on our coding adventures. Until next time, happy coding!